Okay, so hi, I'm Avni Aggarwal.
And I'm Soth Lopez, and we did the GPSP project prompt of the Game On, which is essentially creating a math themed board game, and we based ours off mostly Candyland and Monopoly.
So when we were researching, we learned about a couple of board games and what made them so popular. So the first one we did was Monopoly, and according to a magazine I found, what makes Monopoly so popular is that like every player can always think that they're gonna beat the other guy because they always have like control over what happens to them because they make all the decisions. So we tried to incorporate that here by not making it completely Candyland and like letting them have some control over what happens to them by letting them solve math problems.
What made Candyland so popular is that it was developed around the time when polio was a big thing, and obviously they couldn't move. But like playing the game Candyland, it simulated moving because you have these little people like characters, and you move them around the board. So that's something that made them feel like they could move, and that was really positive for us. So we included both of those incorporations to our game because it has the basic elements of Candyland. You know, you're trying to get to the end of the board. There's different cards. We're like, okay, 2 yellows. But we also added in bits for like Monopoly, where you have a little bit more control. When you use math cards before every single turn, they're about Pythagorean theorem. They're different. They can be word problems, ones like this. It's many different things, but then that makes you have a little bit more control, so it's not that you feel helpless.
Yes, also we kind of tried to simulate the purpose for Candyland too, because Candyland was developed in a time where people couldn't move very much, and it helped them feel like they could move. And now a lot of parents want their kids to start learning higher level math before it's actually introduced in school. So we developed this so that it's a fun way to get kids introduced to new topics and stuff that they're gonna learn later.
Most of our things were our project mostly made of recycled products. Like this is an old Amazon box. The board game was made of an old Amazon box. This was from one of the giant sticky note things. And then we repurposed some Candyland characters and cards while still making our own ones. So we're not buying a fancy like board game template to create and things like that. We made it mostly out of recycled materials, and I feel like it looks really good that way, and it feels like a more authentic feel, not like one of the corporations like that are like soulless and just like mass producing when it's like not actual like hard putting to it.
We tested this on an audience of 3rd, 4th, and 5th graders, and we had them play it, and them and their parents had to fill out a survey after that. So some of the feedback we got was like, could we include more topics on this game? But since we decided that it was just going to be Pythagorean theorem, we decided not to utilize that suggestion. Something else we heard was, can you include different types of problems? Because originally we only had like triangles, and it was like find the missing side.
Yeah. All we had were these, but then we incorporated more word problems into it, so they have to expand their reading skills also, not only their math skills, and then it's like multi-purpose game.
And then we just heard mostly positive stuff. Oh, another common one was, can you add more? Because we originally had just 10 or 15, and they were getting reused too many times, so kids already knew the answer. But for the most part, the results were really positive. On a scale of 1 to 10, the level of funness, I guess, the level of intriguingness,
like the way how much you learned from it,
and how likely they were to buy it.
That was all 8s and above,
yeah,
and some of them were 9s or 10s.
Yeah,
only 9s or 10s. So then I feel like that was for both the parents and the kids. Also, another suggestion with the kids was to make a couple more of these little pathways, like memorization lane and calculator way, so that it makes it easier for you to get ahead on the map, and also incorporating more of the special spaces such as a squared, b squared, c squared, and things like that to make you skip a lot of the map.
Yeah. So something else we decided to incorporate was, you know how Candyland has those little licorice woods and stuff? So there are cards mixed into a little card pile, like this one. And this one is b squared, right? So if you get b squared, you can either hop directly to B squared,
With
or
Mr. Beast Math Lab.
with- at
You have
Mr.
characters
Beast.
for each of them.
yeah, or you can wait. And if you get A squared during the course of the game, then you can use both of them, and you can hop right up here to C squared,
Which is the highest the highest one in the board. And we made little characters for each one. Like this is Miss A's art studio, and see they all have little triangle heads, like the triangles. And then we also wanted them to not just have, that's just a couple of fun facts. So this one, so Pythagoras believed that the earth was round, and that obviously was correct. So we have a little character called Mr. Round there.
And then over here, it says Pythagoras believed that musical notes had mathematical equation translations, so we made the equation recording studio over here.
We also have a couple squares that make you that help your playing time, but it doesn't make you bump ahead, things like that. For example, there's this one which is computation error. You lose a turn, and the little 1 + 1 = 3.
Over here it says teacher's pet, so you get to take another turn.
Over here it says caught cheating, so that means that you have to do multiple math problems the next turn.
And right there. Oh, right there. This one says extra credit, so you don't have to do a math problem on your next turn. A problem card and solve it. So you just pick up the top one and you solve it. And the answer for this one, I think, is 5.2. And if I check with
Which number is it?
number 45.
The answer is 5.2. So that means that she gets to pick one of these cards.
Okay, so I got one green, and I moved to the next green space. And then since this is calculator way, I can move across the bridge and go here.
So that
Now
means,
it's Ella's turn.
so she got to skip all of this things.
Yeah.
So now I pick up a card. And then this basically says, this one is number 47.
47 is 2.7.
So that means I also get to draw a card.
Yeah.
And that means I get 2 yellows, so I get to go to this yellow and this yellow, right here.
And so that basically repeats until somebody reaches the big neon pink triangle at the end, at which point that person has won.
Yes, we're going to keep playing it a little bit just to show.
Yeah.
And then that's basically what the game is.
Yeah. Is the answer for number 49 42.5?
Yes.
Okay, so I'm gonna draw a card.
And this one's a special card.
So this one is a special card, and it has this little symbol on it. So if I go to the map and I find the space with that symbol on it, I can move all the way up here.
So now she's very close to the finish line.
Yeah. So, but if I get on one of these little like things, like this one says extra credit. So I don't have to do a math problem in order to draw a card on my next turn. Or like this one, where is it? It's like here. It says caught cheating, so you have to do 2 math problems next time. And this one says computation error, so you don't get to take your next turn. So basically they're like little
The little action cards, like in Candyland, it'll be stuck on a licorice space.
Yeah, so it can either like help or hurt your progress.
It's number 4823.3.
Yeah.
So we got 2 greens right here. 1 green, 2 green. If we make another game, if we make a new development of this game, then we would probably add a couple squares and we like go back X amount of spaces or go forward X amount of spaces, because that was another one of the feedback. And since we had already done most of the squares, it would have been much harder to add those in. So we decided to not apply that feedback at that one point. But if we do another thing similar to this, then we would obviously do it again.
Yeah. So thank you for listening to our presentation.